Hi, I'm Harvey Hill, and this is my presentation over the copper reaction lab. The background information, this experiment involves 5 reactions, starting and ending with the element copper. This will demonstrate chemical transformations while conserving mass. In this lab, we will be practicing the law of conservation of mass. We will do many reactions like with nitric acid, copper nitric solution, nitric dioxide gas. We'll add water. We'll observe color changes and gas evolutions. We will heat the substance. We will have certified steps to go with the lab. Our objective, we are demonstrating the law of conservation. We are carrying out a sequence of chemical transformations. We're identifying examples of major reactions like redox, precipitation, and decomposition. We are applying stoichiometry principles to compute percent yield and measure the initial and final copper masses. We are building proficiency in both theoretical concept and hands-on laboratory procedures. The methods, don't worry about the methods right now. We're mainly looking at the materials. The method is basically there just to give y'all like what it's gonna go into. The next few slides will show y'all like the steps of the method, but the materials will be a copper wire, concentrated nitric acid, sodium hydroxide, sulfuric acid, zinc, distilled water, methanol, acetone, 100 milliliter beaker, graduated cylinder, hot plate, porcelain, evaporating dish, 250 milliliter beaker, stirring rod, electronic balance, fume hood, gloves, goggles, lab coat, camera, and phone. That was the materials that we used for the lab. Right here, we're adding 2.5 milliliters of concentrated HNO3 being added to the copper. Right here, and you see the color change. The reaction 2, we added 50 milliliter of water was added to the reaction, and then we added NaOH to the solution. It turned blue. And then we slowly heated it to the substance. We slowly heated the substance and waited till it turned black. We then used a decanting method, and we decanted it to keep the black substance. And we added more water because we were trying to fully wash away the acid and NaOH. And then we added 7.5 milliliters of sulfuric acid to the CuO substance. We then weighed 1 gram of zinc to add the substance, and then we decanted it. And then we added acetone to make sure the Cu was fully by itself and decant that. After that, we recorded this mass to make the calculations for the experimental percent yield. These are the safety and disposal rules. Corrosive, there was corrosive stuff like the acids, the sulfuric acid, the sodium dioxide, and other stuff. We wear gloves and goggles for it. There was toxic gases, which is why some of the stuff was lit under the fume hood. Like when we added the copper to the, I believe it was HNO3, and we added that to the copper. We had to do that under the fume hood because of the gases, or when we added the zinc to it, there were certain gases that just weren't safe to inhale, so we used the fume hood. There was flammables, which is also used under the fume hood. Aqueous gases were washed down the drain, organic rinses, and the copper was just thrown in the trash. We had 100% yield rate. We started with 4.49 grams, and we ended with 0.45, which is over the dish. Over what we original had, so I believe something went wrong with the weighing when we were using the plate that measures it. The discussion, maybe it was mainly over. We got it, the 100% yield rate, mainly because of how we did the weighing. The dish really wasn't too specific, so I believe that we got some of it wrong, but mainly it wasn't too good for us. We could have went better with, understand what we were doing using the acids. Mainly, but it was mainly just weighing for us that really brought us down and like kind of made a lot of stuff confusing. And that's it. And these are references. Thank you.